Greetings. Welcome to Paraclete Academy's Essential Mathematics Level 10 course. We are at the very start of this course, and we are within student view, so you can see exactly what you would be seeing as a student. This is the lecture aspect of the lesson. And this is assuming that you have already completed the Start Here First Chapter 1 prep test, which you certainly would want to do. I appreciate your patience in advance. My computer needs a cup of coffee and is slightly sluggish. So from here you would have completed that, you would have submitted that assignment, and then you click Next. So the pathway of going through the course will be for students to be in the module section and click on the Next and Previous buttons. Okay, so we're here, section 1.1 within chapter 1, Introduction to Whole Numbers. And we are going to go ahead and switch over here so that we can really begin the lecture part of the course. So we'll go ahead and get started. And we see that we were in section 1.1, which is Introduction to Whole Numbers. Okay. This lecture covers Objective A. So within every chapter, within every section actually, there are objectives, which is another way for saying, what am I supposed to get out of this section? What is it that I will, as a math practitioner, be able to do once I've learned this lesson? Okay. And in this one, we're talking Objective A, which states that the student, after learning the lesson in Objective A, will be able to identify the order relation between two numbers. This is the goal for Objective A. So let's go ahead and get started. So whole numbers are the following. You have 0, 3, 4, 5, 6, 7, and so on. The 3 dots mean and so on. So there are two characteristics of a whole number. The first characteristic of a whole number is that it is a whole, that is to say, an entire number. Okay, it's not part of a number. So for an example, when she's baking cheesecake, she is dealing with parts of a number. She may be getting a 1/4 cup of cream cheese, just for an example. Okay. The 1/4, the 1/4, is not a whole number. That's a fraction. Okay. So we are not dealing with parts of a number, which would be a fraction or a percentage. We are dealing with whole numbers, which are complete or entire numbers. The second characteristic or property of a whole number is there is no largest whole number. Okay, Mr. Lampley, what exactly do you mean when you say that? I mean exactly what I'm saying. There is no largest whole number. So from 0, 1, 2, 3, 4, 5, 6, 7, and so on, the numbers just keep going off into infinity. There is no such thing as a largest whole number. Okay, so we're representing these numbers here. We're 0, 1, 2, 3, 4, 5, 6, 7, and the 3 dots, of course, mean and so on, or off to eternity. Sorry, infinity, forgive me. This is not a theological lesson. This is a mathematics lesson. So they go off into infinity. Okay, and we can actually use a number line to... So this is what I mean when I say that. Okay, I can draw a number line so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the arrow in a number line means this very same thing as the 3 dots. And so on, off into infinity. Okay. So this is a number line, and if I wanted to a whole number on a number line, say for an example that I needed to, and this is actually called the graph of a whole number. Let me write that for you. The graph of a whole number. So to graph a whole number, I would use a number line, and I would need to know what that number is. So say for an example, if I received the directions to graph 3 on a number line. I would have a number line, and I would place a big dot over the number 3. That would be the solution to graphing 3 on a number line. Okay. So what's really handy about number lines, and I'm going to put this like so, just so that, whoops, not too far off, so that you have the ability to kind of take a look at that. Of course, you could also pause the lecture as well, so you can see that information. So I'm going to go ahead and continue with the lecture. So the number line can be used to show the order of whole numbers. Okay? So let's look at this number line. So now we're going to be talking about the order of whole numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So let's not forget that that arrow does actually mean that the numbers just keep going, and they don't stop. They never end. Okay? So number lines are very handy because they help us to be able to determine the order, and not only the order of numbers, but the order relation between two numbers. We'll get to that in a moment. Let's just go ahead and talk about the order of numbers. So for an example, if I were to graph the number 5, and I do that by placing a big dot on that tick, that line right above the number 5, I notice that the numbers have a particular order. So that is to say that everything that is to the left of the number 5 is less than 5. Okay? And that's also to say that if everything to the left of the 5 on a number line is less than 5, then we must also say that everything that is to the right of the 5 on the number line is greater than. Okay, so we have a given number, and that number here is 5. Everything to the left of the 5 is less than. For an example, 4 is less than 5, 3 is less than 5, 2 is less than 5, 1 is less than 5, and 0 is also less than 5. So if everything to the left of the number 5 is less than, we can also say that everything that is to the right of the 5 on the number line is greater than. 6 is greater than 5. 7 is greater than 5. 8 is greater than 5. And so on, and so on, and so on. Okay? So now that we're able to determine that from one point, everything to the left of that point is less than, everything that is to the right of that point is greater than, let's talk about the order relationship between two numbers. Okay, so we have a number line. And let's draw the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a terrible 9, Mr. Lampley. 9, and so on and so on. Okay? So now, let's talk about the order relationship. Since we've determined less than and greater than, let's go another step up on the rung of mathematics skill. And let's talk about the order relationship between two numbers. A number line also the order relation between two numbers. Another way to say that is the relationship between two numbers. Okay? So if we look at, say for an example, 3. And then let's say we look at 6. Okay? I can tell, and I bring the numbers down, or actually I don't even have to do that. Just from here, from the 6, I can tell that 3 is less than 6, because on the number line, 3 is to the left of 6. Now, once again, this is about a number line. So we're using this number line thing, and we're going to write it all the way through. Okay? So we know that everything, given it, just like up here, given the two numbers that we have, everything that's to the left of this number 6 is less than. So I know that 3 is less than 6. So I'm going to write that here, 3 and 6, and there's a space in between. So one of the great things about math is that math is its own language. Okay? Math is a language. It has its own grammar, it has its own syntax, it has its own vocabulary, it has its own grammar, right? The way that you put the words together to make sense. Math is the very same thing. Math is a language. As a matter of fact, it's been called in science the universal language, but I digress. Let's get back to this. So we have 3 and we have 6. Okay? So math also has its own way of writing things. It has its own symbols and it has its own codes and ways to write things. So I can actually write out 3 is less than 6, or I could use a symbol as a shortcut that says is less than. And that symbol would be an arrowhead pointing toward the left. And we know that that symbol means 3 is less than 6. Well, why does that symbol mean that, Mr. Lampley? Think about the number line. That is to the left of a given is less than. Okay, that's why an arrowhead pointing toward the left means is less than. And instead of writing out the words, I could just use that symbol instead of writing those 3 words. Okay, so incidentally, we have 6. So now a relationship between 2 other numbers. We have 6 and we have 8. So let's look at 6. And let's write those numbers down. So I've got 6 and I have 8. On a number line, is the 8 to the left or to the right of 6? And it's really easy. All we do is just look at the number line and see where it's at in relation to the 6. So if we look at the number line, we see that 8 is actually to the right of the 6, which means that 8 is greater than 6. But when we read, just like we read with math, right, or when we read with English, excuse me, I could use some coffee myself, we read from left to right. Okay, 6 and 8. And the way we could read this problem is, what relationship does 6 have with 8? As far as the order relationship. Well, we know that 6 is to the left of 8, right? So let's look at the number line to help us understand. 8 is right there. 6 is right here. So anything that's to the left of a given number is, so we know that 6 is less than 8. Or I can write out the 3 words, but I like shortcuts, so I'm going to use. Now here's another thing. If we say that 6 is less than 8, we are also saying, with the same equal amount of enthusiasm, energy, and truth, that 8 is greater than 6. It means the same thing, and you're saying the same thing. You're just saying it in a different way. Okay? So let's write that out. We can even use these dots. Let's do it this way. Okay? Let's say 6 and 3. And the way we can read this is, what order relationship does 6 have with 3? What order relationship does 6 have with 3? Okay? So we see the 6, and we see the 3. So is the 6 to the left or to the right of the 3? Take a second to think about that. If we take a look at the 3, we see that the 6 is to the right of the 3. And we know from up here that anything that's right of the given number is greater than. Okay? So here we can write 6 is greater than 3. Or we can use the symbol, and I already kind of gave it away right here. Sorry, spoiler. We have that the symbol for greater than is an arrowhead pointing toward the right. Now, why is that? Well, because if we look at a number line, numbers are greater when they're to the right of a given number. So that arrow pointing toward the right means that the numbers are getting larger, they're getting bigger, they're greater than those numbers that are toward the left. Okay? That's why we use an arrowhead pointing toward the left. Okay? So I could write 6 is greater than 3, or I could say 6 and use the symbol that says the same thing, is greater than 3. Okay, so we have a couple of exercises to try out, so let's go ahead and take a look at that real quick, okay? So we have an example here. It says it's example 1. And example 1 is located on page 3 of section 1.1, so that's example 1. And the directions are telling us to graph 11 on the number line. Okay, so let's draw a number line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And let's draw the marks on the line so we know where we're at and what we're talking about. Okay, so here the direction is graph 11 on the number line. So we know that the way that we do that, and forgive me for using ink pens that are sinking all the way through, but the way that we do that is we place a big fat dot, a heavy dot, on the number. So graph 11, we're going to graph 11 right there, and there we are. Okay, that's how we graph a number on the number line. So example 2. Example 2 is telling us to place the correct symbol, 2 symbols, the arrowhead pointing toward the left or the arrowhead pointing toward the right, between the 2 numbers. Okay, so we have problem A, 39 and 24, and then we have problem B, 0 and 51. Okay, so let's take a look at this. Is 39, if we had and the way that we could do this is you could either draw out a number line or you could just kind of think it through. Let's try to think it through, okay? Because number lines are great, but they get real burdensome or cumbersome to use when you're dealing with larger numbers, okay? So let's just try to think it through. If I had a number line, it starts at 0 and it goes on and on, right, with the arrowhead on and on into infinity. The problem is asking me, what is the order relationship between 39 and 24? Is 39, if you had a number line, to the left or to the right of 24? So we have this number line right here, and let's just say 24 is here. If we keep counting, we're eventually going to get to 39. So let's look at this little number line and let's think it through. Is 39 to the left or to the right of 24? It's to the right of 24. So we know that when a number is to the right of a given number, it's greater than. So we're going to go ahead and use the arrowhead that's pointing toward the right, because we know that anything that's to the right of a given number is greater than that number, right? Okay, let's continue. So here we have problem B. What is the order relation between 0 and 51? Let's do the same thing. We have a number line, we have 0. And if we keep counting, we're eventually going to get to 51. So is 51 to the right or to the left of 0? "51 is to the right of 0. So anything toward the right of a given number we know to be, and that we've learned in this session, is greater than that number. So we're going to come here and put the correct symbol in between those two numbers. 0, 51 is greater than 0. So let's write that here. Since we know that 51 is greater than 0, we also know that the opposite is true. The opposite is also true, because 0 is to the left of 51, right? 0 is to the left of 51, and we know that anything that is to the left of a given number is less than that number, right? So here we did it this way. Now we're going to say 0 is less than 51, which is correct. Okay, so we're almost done with this lecture here. So from here, you try it. Now it's your turn. So we have, you try it, problem 1, and it says graph 6 on the number line. Let's draw a graph. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Graph number 6 on the line. I'm going to give you a moment to take a look at that, and then I'll walk you through it. Okay. So we know that the directions say graph 6 on the number line. So we're going to look at the number line. We're going to find the number that we're supposed to graph. There it is. And from there, we're going to put a heavy dot above the number that we're supposed to graph. And that is a graphed number 6. Let's go to you try it. You try it number 2 says place the correct symbol, and then it gives us the symbols between the two numbers. Okay, so problem A gives us 45 and 29, and then problem B gives us 27 and 0. I'm going to give you a few moments to go ahead and work on that, and then I'll walk through the problem and we'll compare our answers and see if we got it correct. Okay, so let's take a look. This problem A is asking us, what is the order relation between 45 and 29? So the question is 45 to the left or to the right of 29? And eventually, as you get forward, you're just going to say, what's the bigger number? Is 45 the bigger number, or is 29 the bigger number? But I still want to think within the concept of the number line. That's the reason why we're doing it this way. But eventually, you're going to have this memorized to such an extent, it's not even going to matter anymore. You're going to go, what number line? Okay? But right now, white belt. We've got to start at the basics, okay? So, we know that 45 is actually to the right of 29. If we had a number line and we were counting by ones, we know that we would eventually get to 29. And if we kept counting, we would get to 45. Okay? So that is to say that 45 is to the right of 29, which means that it's greater than. 45 is greater than 29. The directions. They don't want us to write the words. They want us to use the symbols. So that means we need an arrowhead that is pointing toward the right, just like this over here, and that means greater than. Okay? I'll give you a moment to take a look at problem B, and then we'll compare notes on that as well. Okay, this might seem a little tricky, but it's not. It really isn't. So the question is, what is the order relation between 27 and 0? Okay, and we're going to ask ourselves the same question in our mind. Is 27 to the left or to the right of 0? Well, that's a pretty easy question to answer right now. With our number lines as they are, dealing with whole numbers, every number line starts with 0 and then moves further toward the right. So we can say that 27 is to the right of 0. And we know that any number that is to the right of a given number is greater than that number. So let's go ahead and use that symbol. 27 is greater than 0. Okay, so that's objective A. Congratulations, you made it through the lecture. That's objective A. The objective is to identify the order relation between two numbers. Just as a quick recap, we covered whole numbers. Whole numbers start with 0 and go off into infinity. Whole numbers have special properties. Well, they have particular properties, let's put it that way. The first property of a whole number is that it's a whole number. It's complete. It's not a half, it's not a part, it's not a percent. It's a complete number. And the second property of a whole number is that there is no such thing as a greatest whole number. It just keeps climbing on into infinity. We can write out the numbers, and when we're tired of writing out the numbers and we just want to say and so on off into infinity, we use 3 dots. Okay? When we're using a number line and we get tired of writing numbers, we just put an arrowhead toward the right. We also learned that when you have a given, that we learned how to graph a number, right? And the way that we graph a number is we put a heavy dot above that on the number line, and that teaches us to identify a specific number or to have a given number. The next step on the rung of mathematics skill, once we get past being able to graph a number, is we get to talk about order relationship between numbers. So the next step up is that once we can identify a given number, then we can look at a second number and see what the relationship of that second number is to the first number. Okay, and we have that given number. We'll use 6 as an example here. Anything that is to the left of number 6 is less than. Anything that is to the right, the given number in this example, is greater than. So anything that's to the right, greater. Anything that's to the left, lesser. So that we can not only graph numbers, but now we also understand the order relationship between those two numbers. And we can do that with any two numbers. Now you have the skills. Now you know what to do in order to figure out the order relationship between two numbers. Now you might be taking a look and saying, big deal. What's the big deal in that? Why do I need to know the order relationship between two numbers? You need that so that you can do anything else in math. You can't subtract. You can't divide or multiply without being able to understand the order relationship between two numbers. If you're walking down to the store, or you're driving down to the store, and you get a flat tire on the way, you put your spare on and you head down to American Tire, and you're looking at the tires on the wall and you see the numbers, you need to be able to know which tire is more expensive than the other one. And the way that you do that is you look at the order relationship between the price of the two tires, so that you can tell that the $30 Cooper tire is cheaper or less than the $100 Michelin tire. So this is at the very, very basics of your math foundation. Before you can do any mathematical operations, addition, subtraction, before you can do algebra, before you can do any of those things, before you can do any of those things, you have to be able to tell the order relationship between two numbers. Math, by design, is progressive. So we're starting on step 2, because we learned what whole numbers were, and then we learned how to graph. So actually we're on step 3. We went up another step and learned how to graph numbers, so now we number. And then step 3 on these mathematics stairs is to be able to tell the relationship between the two. We're going to continue. It was a pleasure working this with you and talking with you about this. Don't feel like they know this, or you should, but don't feel like, oh, you know what, this is just, kids play and all this other stuff. Everything has a foundation. Every house is built on a foundation. Every set of skills or knowledge, you got to have the basics before you can move forward. So once you get this down and you do the homework that you need to do, then we're going to go to the next lesson, okay? Hang in there. You're doing great, and we'll see you with an Objective B Section 1-1 lecture.